Good morning and welcome. Let's do the two problems where we're calculating the magnitude of the enclosed area bounded by the situations as described. The first one says we need to calculate by using integration the area bounded by or the area enclosed by or the area found between the curve y equal 5 over x. The curve in this case means the graph, and then the x-axis, the lines x equals 1 and x equals e to the exponent 2. Because of space, I want us to do this one, and then we will come back and look at number b. Okay, let's take this one off. Let's take this one off. But we have the curve is y equal 5 over x. We've got the x-axis, lines x is 1 and x is e to the exponent 2. That's what we need to have this. Now let's take this off. When we look at this, we need to first have an idea of the sketch or graph and then show all the other indicators that are there. So when we look at this, this is a hyperbola. This is a hyperbola which takes the form of xy equals 5. If you multiply both sides, you will have this. This is the hyperbola. Now, what is the graph? The graph of the hyperbola would be this xy equals 5 when the constant is positive. In this case it is 5 positive. The graph will lie in the first quadrant as well as in the third quadrant. So this is the graph of xy equals 5 or y equals 5 over x, and then the line x is 1. The line x is 1 maybe here, and the line x is e to the exponent 2. E to the exponent 2 can be given as a value. Now this e to the exponent 2 is same as 7.389. So e to the 2 same as that. So I can then say this is e to the 2, which is same as 7.389. Now the area enclosed between is this area here, which is this area here. This is the area enclosed between the graph. The line x is 1, the line x is e to the 2. That is the area. That is the area that we need to calculate the magnitude. So we will always have this dx, and this is called the representative strip, which we are going to use to calculate the area of the representative strip, which we will ultimately use to calculate the total area. Now the area of the representative strip would be dA equals y dx. This is what we will use to calculate. Now, what is this What is this y? y y is 5 over x dx. This is more like the area of the strip is a y as the length and the dx as the breadth, but we're only talking the strip, not the total area. So for us to find the total area, we need to integrate, because this sign means summing up or bringing together or grouping together or summing together. We're going to sum all the strips of 5 over x dx, sorry, and then this we will sum from e to the 2 to 1. Now this will then be, we need to integrate. When we integrate 5 over x, the integral will be 5 ln x e to the 2 and 1. So we know that the rule says we will need to substitute x by e to the 2 minus 5 ln 1. And what is the ln of 1? 0. What is 0 by 5? 0. Minus 0, 0. So this part falls off. So area safely can be 5 ln e to the 2 square units. Square units. If we knew that this is in meters, this will be meters squared. If we knew this was in millimeters, so it will be millimeters squared. But now some might want to have this value. Some might want to have this value. What is this 5 ln e squared? Sorry. The response would be ln that by 5. So this gives 10 square units as the answer. We have calculated the magnitude of the area, and then thank you for watching. See you in the next question, which is our number B. Thank you.